Hey everybody, this is the Aldol Condensation lab. Here's the outline for the video. I'll be going over the reaction and the mechanism and then briefly going over the procedure. Then I'll show the experiment in the lab. Now this lab is pretty straightforward and pretty quick, so this will be a shorter video. Here's the reaction that we'll be doing. We're taking benzaldehyde and reacting it with acetone using sodium hydroxide to initiate the reaction to form dibenzyl acetone. Notice that there are two aromatic rings on the product, meaning that two benzaldehyde molecules are required to react with each acetone molecule. So when looking at the millimoles to calculate your percent yield, keep that in mind and remember that benzaldehyde will be used up twice as fast as the acetone. Here's a look at the mechanism. The hydroxide will pull off an alpha hydrogen from the acetone to create an enolate intermediate. And the resonance that exists on that intermediate creates a nucleophilic carbon that can then attack the carbonyl on the benzaldehyde. Now, since benzaldehyde doesn't have any alpha hydrogens, there's only one product formed as the hydroxide only reacts with the acetone. Through this, a beta hydroxy ketone intermediate is formed, and through an E1CB mechanism, we get to our dibenzyl acetone product. And in this reaction, the product formation is favored because it will precipitate out of solution as it is formed. We'll be performing this reaction at room temperature in a conical vial attached to an air condenser, and as the reaction progresses, we'll see the yellow product precipitate out of solution, and we'll let it react for about 30 minutes, after which we can collect the crude yellow product using vacuum filtration and rinse that solid with some water and acetic acid just to remove any remaining base that might have been left over. Then we'll recrystallize the crude product using ethanol as a solvent and characterize those crystals by taking a melting point and running an IR spec. I'll be adding all the reagents to the conical vial, starting with 240 microliters of benzaldehyde, and then I'll add 90 microliters of acetone. And finally, I'll add 2.5 milliliters of the sodium hydroxide, which is in a water ethanol solution. Then I'll set up the apparatus and let everything react for half an hour. And you can already start to see the yellow solid precipitating out of solution, and it'll continue to form as the reaction progresses. Once the half hour has passed, everything can be transferred over to the Hirsch funnel to start separating the solution from the product. I'll rinse the conical vial with some distilled water to remove as much product as possible and do my best to remove the product from the spin vane as well. I'll briefly rinse that solid with some distilled water while breaking it up with a spatula and stirring it around. Once it's dry enough, it can now be moved over to a beaker where I'll be adding 5% acetic acid and ethanol to react with any remaining base. And I want to make sure to stir and break up the solid so that it interacts with the acetic acid as much as possible. Then I'll place it back into the Hirsch funnel and rinse that solid a few more times with some more distilled water. After letting it dry, the crude product can be taken out and transferred over to a Craig tube where I'll begin the recrystallization process. Ethanol will be used as the recrystallization solvent, and I'll add it to the Craig tube while stirring the product until it is fully dissolved. Then I'll test that the product can come out of solution in an ice bath, and was having a little bit of trouble. I had to scrape the sides of the glass with a spatula, so when I put it back in the hot water bath to dissolve the product, I ended up evaporating some of the solvent off. And now I'll leave the solution out at room temperature so that the product can recrystallize slowly. I'll break up the crystals a little bit, just so they'll be slightly easier to remove, and then use the stopper and a test tube to separate the crystals from the solution, and I'll let it run in the centrifuge for a couple of minutes. Once I have the pure crystals, I can weigh them out to calculate a percent yield, the empty watch glass being 9.736 grams, and the full watch glass being 9.853 grams. I'll acquire a melting point range for the product, starting a few degrees lower as usual. These crystals started melting around 111 degrees Celsius, which is a little lower than expected, and didn't finish until about 112.6 degrees, so I may have added a little bit too much sample this time. Finally, I'll run an IR spec using the Nugel mold technique. And it looks great. We have the ketone peak around 1650, an alkene peak around 1590, and some aromatic overtones. So that turned out pretty well.